Hello, Algebra 2 students. I appreciate you finding time to get your notes taken care of. Today we're going to be looking at a little bit deeper into the mathematics of what the laws of logarithms can do for us to help us solve problems. Our objective for today, to learn to use the basic laws of logarithms in order to simplify expressions. Now, there are three laws of logarithms. We have already messed with one of them a little bit toward the end of the exponential functions unit. And we're going to see two more laws today, and their main function is to help us get past some places in some equations where we are trying to solve for a particular variable but may not know what to do in order to get that variable by itself. As always, anytime you need more time, press pause and then hit play when you're ready to move on. Okay, so as we learned last time, logarithms are exponents, and we probably had a little fun trying to get our heads wrapped around how to convert from logarithmic to exponential and exponential back to logarithmic forms. Okay, but just like exponents, our laws of logs, or we have laws that go along with our logarithms. Okay, now law 1 should look somewhat familiar to you because it is basically the same as law 1 for the laws of exponents. Okay, and basically, if you think about law 1 for the laws of exponents, if the bases were the same and being multiplied, then the rule was the values, the exponents could be added together. Well, you can see traces of that in this law. We see log base b of m times n. So that could be two numbers or values there in the argument being multiplied together, the m and the n, or possibly m and n could be factors of some larger value. And anyway, the result of that, or what the law says that you can do, is you can split that argument into two different logarithmic terms that are being added together. So log base b of m plus log base b of n. Now also keep in mind that equations, of course, can be read from left to right, and they can be read from right to left. So it's possible that we might be using this law not to split an argument into a binomial using two logs, but possibly to turn a binomial of two logs into a monomial. So we might be looking at it from right to left, log base b of m plus log base b of n, since they are both logarithmic terms and the bases both match, then we can multiply the two arguments together and get a single logarithmic term. Okay, please note on the law that on all three occurrences of the logarithm in the equation, okay, all of the bases match. If you had a base that was different in there, then you would not be able to use this law. Okay, so let's look at an example of this in action. Okay, log base a of 4 plus log base a of 6 equals log base a of x plus 4. Okay, well, as we can see on the left side of the problem, we have a binomial of two log base a terms. Law 1 from above tells us that we may combine those two logarithmic terms into a single logarithmic term by multiplying the two arguments together. Okay, so the 4 argument on the left term plus the 6 argument on the right term, 4 times 6 is 24. Now, if you can get to a spot like this in an equation where basically you have a monomial on each side, log base a of 24, log base a of x plus 4, okay, that's a single term on each side, and they are both logarithms of the same base, log base a on the left, log base a on the right. Then those can be canceled on both sides of the problem, which would leave just the arguments, 24 on the left and x plus 4 on the right. then the only thing you would have to do in order to solve for x would be to get the plus 4 off of it. And of course we can move that by subtracting 4 from both sides, which would make x equal 20. And there you go. We were able to take an equation that we had no idea what to do with it and simplify it to the point where we could find the value of the variable just by using law 1 of the laws of logarithms. The second law should look familiar to you somewhat as well. Very similar to law 2 from the exponents. It deals with an argument that has division going on. So we see on the left side of the problem there, log base b of an argument m divided by n. The law says that that little quotient there, that little division problem, can be split into a binomial log base b of m minus log base b of n. And of course, still keep in mind that equations read not just left to right, but also right to left. So we could also take a binomial that we have in the problem, like the right side of this problem, and convert it into a monomial. Okay, and the same rule still applies. This is assuming that you are using the same base value in your logarithmic problem. Okay, so let's see this one in action. Solve log base 4 of x plus 6 minus log base 4 of x minus 1 equals log base 4 of 5. Now please notice that all of the base values in the problem are the same. They are all log base 4. That means we can apply the laws of logarithms. Now we see that on the left side we have a binomial log base 4 minus a different log base 4. Law 2 tells us that we can turn this into a single term, a monomial, log base 4 of the first argument divided by the second argument. So that would be x plus 6 over x plus 1. Now we find ourselves in the same spot that we were on the previous screen. We have a monomial on the left, monomial on the right. They are both log base 4s, so we can cancel log base 4 from both sides of the problem. That would leave just the division problem, x plus 6 over x minus 1 on the left and equals 5 on the right. Now, if our goal is to solve for x, then obviously we're trying to get x by itself. We want it isolated. And one of the things we have said all along is that you will never be able to solve for a variable as long as that variable is in the denominator somewhere. So at our first convenience, we ought to try to get any variable out of the denominator. Okay, so you can see on the left we have x minus 1 in the denominator. We need to get that out of there. Well, currently x minus 1 is dividing. So if we want to get it out of there, we would need to multiply it out. So if we multiply both sides of the problem by the binomial x minus 1, we would end up with just x plus 6 on the left, and then 5 on the right is going to be multiplied times 5x, multiplied by x minus 1. Now keep in mind the distributive property applies here. We have a monomial times a binomial, 5 times x minus 1. So the 5 needs to hit both of the terms in the binomial, so that'll give us 5x minus 5. Okay. Now we should be pretty much in the clear. All we have to do is finish off our 5 steps to solving an equation. The next thing to do would be to identify that we now have x's on the left and x's on the right. We do not want them scattered all over the problem like that, so we would move them one direction or the other. I think I would move all of my x's to the right. That would still give us a positive x value, which is what we want. And then I would move all of the constants to the left. So I'm going to be subtracting 1x over to the right and adding 5 over to the left. That gives us 11 constants on the left, 4 x's on the right, and of course you don't want 4 x's, you just want 1. So if you divide by 4, we're going to end up with improper fraction or a mixed number or a decimal point or whatever. Okay, but 11 divided by 4 is the value for x in this case. Okay, one more law, and this is the one that we should be familiar with. We use this law to help us out with the exponential function, and this one says if you have log base b of m to the n, that you may bring the exponent out in front of log as a coefficient, and then your argument m would no longer have any other exponent than just a 1. Okay. Also, again, the equation does read backwards as well. So if you found the need, if you had a coefficient in front of your logarithmic term and wanted to get that coefficient out from in front of it, you could always put the coefficient back onto the exponent of the m. Okay, so let's take a look at where this might be helpful. Okay, here we have solve 3 times log base b of x equals log base b of 8. Now, as with the other two laws, make sure that we are operating in the same base. In other words, we would not want one base value of a log on one side of the equal sign and a different base value of log somewhere else in the problem. We would not be able to proceed unless the bases match, which they do. Okay, now we are very close to the same step we've seen in the last two examples where we have a monomial on the left and a monomial on the right, and we could cancel the logarithms. Okay, however, one of our logarithms has a coefficient. The one on the left has 3 log base b's of x. Okay, well, we really don't want 3. We really just want one of them. And if we just had 1 on each side, then we could cancel the logarithms. Law 3 says we can take that coefficient, 3, and we can move it to the exponent of the argument x. Okay, so moving the 3 back up to the exponent, we haven't used this law that way yet, but now we see that that can be done. Now you have log base b on the left, you have log base b on the right. We can cancel the log base b's in both cases, and that leaves us just the arguments. X plus 3 equals 8. Okay. Now, you probably already know the answer to this one, but let's go ahead and finish it off. How do you get the 3 off of the x? Well, the opposite of cube is cube root. So we're going to take the cube root of both sides. Okay, or you can also think of it like with the reciprocal exponent idea, like we've been doing all along here. Raise both sides to the 1/3 power. Okay, and the cube root of 8 is 2. Okay. Now, as you can probably imagine, just like with the exponents, these problems are not going to just come at you one law at a time. You will have possibly many instances of the laws of logs coexisting in a problem together. It'll be up to you to decide when and where those laws might apply. Okay, so we're looking at a problem here that looks fairly challenging. Solve 2/3 of log base 12 of x, and that is going to be equal to log base 12 of 4 plus log base 12 of 16. An important thing to recognize right off the bat is whether or not the bases of the logarithms are all matching up, which they are. You would not want to use any of the laws of logarithms if the bases were not matching. Okay, so I see a couple of things here. First off, on the left side of the problem, we have a coefficient of 2/3. As we saw in the last problem that we worked together, it could be beneficial if that 2/3 would go back to being the exponent in the argument. So moving that to be x to the 2/3. Also, on the right side of the problem, we see that we have 2 log base 12s being added together. Law 1 says that those terms can be combined by multiplying the 2 arguments together. Okay, so let's just kind of take a step Okay, and there I have done both of those things that I just said. Law 3 allowed us to move the 2/3 coefficient on the left to the exponent of the argument, and Law 1 allowed us to combine the binomial into a monomial on the right by multiplying the argument 4 and 16 to get a 64. Okay, now that we have basically the equation is balanced, we have log base 12 equals log base 12, so we can remove the log base 12s, and that would give us x to the 2/3 on the left and 64 on the right. So the final thing to do is that we have x to the 2/3 power. Well, we don't want x to the 2/3 power, we want x to the first power. So to get that exponent off of our x, we would raise that to another exponent that would cancel 2/3 out. And of course, the thing that will do that is the reciprocal of 2/3, which is 3/2. So we're going to raise both sides of the problem to the 3/2 power. Okay. On the left, that will leave just 6. And 64 to the 3/2 power is probably a number that you are not familiar with, so we would probably be on our calculator trying to get some help on that one. And it is 512. These problems are checkable. Once you solve for a variable, just like any other equation, you can always take it back to the problem and plug it in for x and see if the equation balances. Now you may need some help learning how to type all that log base 12 stuff into your calculator. So if you are really interested in learning how to check it, I will be happy to show you how the calculator works with that. Anyway, that's kind of the end of it. So we're going to need some practice on this, obviously. We got some new rules. So I appreciate you finding time to get your notes taken care of. Hopefully that wasn't too terribly complicated, but I think you'll get the hang of it once you work some problems of your own. Anyway, I will see you in class.